Project Bluewater 2 is a practice change project to assist sugarcane growers in the Great Barrier Reef catchment to look at their pesticide usage and choices and how they impact on the local freshwater environment in the region. This project has been funded by the federal government through the Great Barrier Reef Partnership Trust with GBRF, the Great Barrier Reef Foundation. It has been identified in water sampling through the catchment that pesticide runoff from farmland is causing exceedances in the local freshwater creeks, rivers and streams of the catchment, and these exceedances have been in excess of the PC95 value, which is the safety threshold that we measure the toxicity of pollutants in waterways for the safety to microorganisms and the environment in general. Project Bluewater 2 has engaged with 75 growers across 170 farms in the lower Burdekin region, equating to a total of just over 19,000 hectares of sugarcane production land. Engagement in the project has been one-on-one with every individual grower. Every grower has received a seasonal plan for their sugarcane where we sit down and we discuss their agronomic options based on their situation, the weeds that they're targeting, results they may or may not have, soil types, a holistic approach to managing weeds on their farm in order to pick the best options for the situation, both from an agronomic point of view and from a water quality perspective. The project has been very successful in reducing risk units, and there's still a lot of scope for improvement with continued and ongoing support to growers. Our experience has been that it takes approximately 3 full seasons to ingrain pesticide practice change into farm management programs, and a number of the growers in this project have only experienced a single season of assistance. The large change that has been experienced from those growers who've only had that single season has still been outstanding. Once the pesticide decision support tool and the risk unit methodology were developed, a target for the project in relation to risk units to the waterway was established. The project was aiming to reduce the risk to the aquatic environment by 576,809 risk units across the project participants. At the completion of the project in May 2024, the project achieved a risk unit reduction in the catchment of 1,607,971 pesticide risk units, which was nearly 3 times the target set at the midpoint of the project. This equated to an overall reduction of 26% in risk to the waterway based on original spray records before the project commenced. As part of the project, Farmacist has been working with local growers and other stakeholders in the region to develop farm plans and upgrade equipment to achieve improved water quality risk outcomes. As part of the support to growers, there was incentive money to assist them to upgrade their spraying equipment. And the reason that this is very important is that if the equipment we're using to apply chemical products is not up to standard or it's not compliant, there's a number of loss pathways that increase the risk to the waterway due to overlap spraying, the ability of sprayers to switch off sections as they come through angled rows and spraying off into drains when it's not needed, and a number of other reasons around drift and things like that in relation to nozzles and pressures, nozzle spacings. So during the project, over 20 booms were completely rebuilt in-house by Farmacist from the ground up, and every single grower was at least provided a set of nozzles that were compliant and suitable for the job that was being conducted. The vast majority had a large overhaul of their boom. This came to a total of $300,000 of physical hardware components, nozzles, nozzle bodies, plumbing, pumps, sensors, rate controllers, GPS systems in some cases, all designed to improve the accuracy and agronomic outcomes from the spray activities being conducted on that property. And education and training was a large proportion of the project as well, educating growers in both water quality and what that means and how their farm influences those results, as well as agronomically what products were better suited for the systems that were being used in terms of products staying where they were put and being available to do the job that they're supposed to do, getting timings right to get the best out of their molecules, and alternative options that might be of interest that had both a better agronomic fit and a lower risk to the aquatic environment. During the project, 6 large-scale data generating field trials were conducted that were able to be analysed using statistical analysis. For those trials and also for demonstration purposes, over 140 end of paddock water samples were taken to demonstrate the movement of product, and on top of that, the learnings from that were then taken to individual farms where farmers put in their own scale trials to help them be comfortable with alternative options and alternative ways of doing things. Following on from the training and education, a large number of workshops were also conducted, bringing in external expertise into the industry to help upskill growers in spray application, sprayer setup, and the technical characteristics of chemicals to help growers better understand and apply products to their farm. 13 workshops were organised by Farmacist, with Farmacist also attending a number of industry events and field days and providing presentations on practice change and best management practice to the industry. More than 50 project communications across many media, social media and other platforms were conducted, comprising of 14 case studies. 7 case study and best practice videos were also produced, and it was found that the video form of communication got the widest reach and the most positive feedback of all the communications platforms that were used. At the commencement of the project, the way of measuring or tracking farm practice change was not well defined, and the challenge was to come up with a methodology to do so. As part of the project, Farmacist, in conjunction with the University of Queensland, developed the Pesticide Decision Support Tool, which is a tool, a nice visual graphic that enables growers to easily compare products that they have available to them and decide which product may or may not be a greater risk to the environment, and thus make informed and educated decisions about the products that they use for any given situation. The Pesticide Decision Support Tool is now a peer-reviewed scientific paper and is available in the public domain for anyone to access. And there is an online portal being developed by the Office of the Great Barrier Reef and the Queensland Government to allow anyone easy access to be able to put in their chosen products and see how they rate compared to the alternatives. The Pesticide Decision Support Tool ranks products according to their ability to move off target, so their ability to move to a waterway in runoff after application. And if they do make it into the waterway, their toxicity in that environment. This allows us to put a numerical value to each individual product and scale it up or down based on application rate and a number of other factors. Because this is a numerical value, Farmacist has been able to develop a methodology to look at growers' records before they enter the project and then after they've finished the project, and see how their practice change has progressed over the course of the project. This risk assessment methodology for measuring practice change has now been adopted by the Queensland Government for future pesticide practice change work. Farmacist would like to thank the Great Barrier Reef Foundation, the University of Queensland, the growers who participated in the project, and the other stakeholders that have engaged with us in the region to assist in enabling practice change in pesticide use management.